The second type of intramolecular bonding, which means within the same molecule, so ionic and covalent bonds are both types of intramolecular bonds. The opposite, or the other type, is intermolecular bonds, which is between molecules. So, for example, between molecules of water. We're going to have a look at intermolecular next week, but for now we're going on to the next type of intramolecular bonding, which is covalent bonds. Covalent bonding occurs between atoms that are sharing electrons in their valence shell, whereas in ionic bonding, the valence shells of one atom are transferred to the other. It occurs between non-metallic elements, so between one non-metal and another non-metal. This is because their electronegativity is very similar. We'll go through electronegativity and what it means in more detail when I return. Each atom thinks that they own all of the electrons and that it has achieved noble gas configuration. One pair of shared electrons, so one electron from one atom and one electron from the second atom, is a single covalent bond, and you can draw it as a dash between the two elements. Electron dot diagrams or Lewis diagrams can be used to illustrate covalent bond formation. For example, for hydrogen, there's one hydrogen with one in its outer shell, another hydrogen with one electron in its valence shell, and so together they bond to form a H2 atom. A covalent bond in which two electrons are shared is called a single bond, and that's represented as just one dash, as shown here. When atoms combine in a covalent bond, the bonds are formed so that each atom is surrounded by a complete octet of electrons, so 8 electrons. The number of covalent bonds formed by an atom depends on the number of valence electrons it has. So it may form more than one covalent bond in a molecule, or it may form a double or a triple covalent bond. The whole idea is that after bonding, they have 8 electrons. They have a share of 8 electrons. These are some common atoms and their Lewis dot diagrams for their conformation. So neon is a full outer shell, fluorine has room for 1 electron, oxygen has room for 2, nitrogen 3, carbon 4, boron has room for 5, beryllium has room for 6, and lithium has room for 7, or it will just share its 1. Fluorine will form 1 covalent bond, oxygen has the capacity to form 2, and so on, as I said. So when we're writing electron duct structures, here are some things that we should be remembering. Count up the number of valence electrons from each atom. Arrange the dots about the atoms so that the octet rule is followed and no unpaired electrons remain. Check the number of electrons in the formula is the same as the total number of valence electrons initially determined. Here are some additional notes to think about. The main one is that there are sometimes more than one correct Lewis dot structure that can be formed, and that if there's one element, such as in carbon dioxide, the first one will be the middle atom. Sometimes more than one electron is shared between atoms. An example of a compound in which this occurs is carbon dioxide. So carbon is the central atom. It has 4 valence electrons. Each side of carbon, there's an oxygen. Oxygen's 6 electrons are arranged around it, and because it's sharing with the carbon's electrons here, oxygen now has a full outer shell. And the same occurs on the other side. So we have oxygen with its 6 valence electrons. It's sharing with the carbon here, so it now feels like it has 8. And it also works for carbon. So carbon had its original 4 electrons, and now it's sharing with the other one. So it has 2, 4, 6, 8. So the octet rule is being followed. So that's our correct formula. Sometimes triple bonds are needed. So in the case of nitrogen gas, which has the formula N2, each atom shares 3 with one another, which forms a triple bond. If we look at the one nitrogen, it has 1, 2, 3, 4, 5, 6, 7, 8, and the same for the other one. So 1, 2, 3, 4, 5, 6, 7, 8. The octet rule is followed. Here's a bit of an overview of the bonding on the periodic table. If you want to have a bit more of a read, or you finish the exercises, numbers 5, 6 and 7 from the same sheet as last time with the ionic bonding, you can look at your textbook. There are questions on page 243, or the information that you might require is on page 233 to 235. And of course, you could also look up my favorite, which is Crash Course, or the Khan Academy as well. That should be able to help.